For this project, I had to create a fully functioning game level within a week, fully programmed and fully produced. Uh, as this was a very short amount of time, I had to manage my time in asset modeling and creating sound and the level designs created in the Unreal Engine. Uh, I did this by creating a time management plan for myself. From looking at the assignment brief, the first problem was apparent, obviously. It had been a few months since I had last done blueprint work or Unreal work, so I spent some time watching tutorials and refamiliarizing myself with the software. To keep within the time constraints, the level designs of other games were reviewed to get a understanding of how to build an interesting video game level. I decided to go with an arena-styled level, as it could be shorter and less complicated than a fully fledged level, such as an action RPG level. It would also reduce the amount of assets needed and the amount of blueprints needed. I decided the softwares that I would be using were, of course, Unreal Engine 4, 3ds Max, and Blender, FL Studio 20, and Photoshop. Some examples of other arena levels include that of Smite, Gears of War, and Call of Duty, as opposed to, of course, game levels such as Dark Souls, that, as I mentioned previously, would have required more coding and blueprints. The genre idea was going to be a shooting game, so a shooting arena game similar to games such as Splatoon. After doing a quick mock-up of a mood board, I got to programming. Before I started, I decided to use a template as it meant that the very base mechanics could already be implemented and I could work on my own custom blueprints. At first, it was going to be a first-person template, but ultimately I decided that a top-down template would be much better. Part of the reason for this is that when objects are far away in real life, they are less defined than when they are up close. So by making a top-down game, the detail on the models and the textures could be made simpler than if it was a first-person game, as the camera would be further away. And of course, doing this would make it easier to complete within the time constraints. To keep in line with industry pipeline and workflow, programming the mechanics and prototyping them would come first. But by wanting to get more work done faster, a quick mock-up of a robot was made in 3ds Max to replace the default human model from Unreal, the default Unreal model. The reason for making a robot over anything else was for simplicity. I could replace the default Unreal model and have an original creation, and I wouldn't have to worry about things like animation, as the robot wouldn't require legs or arms, so to speak, so animating it would be a lot easier to do. So here is a the robot in Unreal Engine. Of course, like I said, he is very simple, doesn't have legs, and his arms don't require movement, so he's very easy to code and wouldn't be much of a pain when it came to implementing in-game. The first thing that I decided to work on would be the spawning mechanics for the enemies. The way this worked was, upon play, it would run a loop which checked the variable of spawn amount, which could be edited in the game world, and it would then run a custom function called spawn character. In this function, the I got it so I set it up so that it would locate the bounds of the spawn that had been set up, and using a line trace would spawn the actors with a random rotation within those bounds. It would spawn a enemy blueprint. Once I had set up the spawning of the enemy, I decided to next work on the enemy robots themselves, and to get them to move to a random location once they'd been spawned. So, the way this worked was by using a enemy AI controller and a behavior tree. The way that I set this up was that once the enemy had been spawned in-game, it would then run the behavior tree and use the blackboard to go along with it. Once this was set up, it would run this behavior tree, going from left to right. The enemy robot would first of all check if it could see the player using its senses, the pawn sensing. If the enemy could not see the player, it would then set a random location within the bounds that had been given. It would then move to that location and then wait, and once that had completed it, it would repeat the cycle until it could see a player. When it can see a player, it would first check if it's in melee range, or rather, at the same time, it would check if it was in melee range. It would then find the player on the map, and using a parallel, it would chase the player, and if it was within melee range, it would also begin to attack the player. The way the melee range was set up was if the collision box on the enemy was overlapped by the player, it would subtract a set amount of health from the player by casting to the variable of health within the player blueprint. Subtract a set amount of health, and of course play a collision sound at the location. One problem that I came across when creating the movement mechanics was that at first they would not move, and I could not find why. After tinkering around for a while, I finally found out that this variable had not been set to move to location, instead it was none. So of course, it didn't know what to do. Once I changed that, of course, it fixed everything and the enemies began to move around. Next up, I decided to implement the shooting mechanics. And the way that this worked was, after setting up a input action fire, which would be the right click, it would cast to the blueprint gun parent and tell it to start shooting. When it had cast to the gun parent, it would begin a custom event of start shooting, which would call to a gun child actor. And the reason I made a child is that each child can inherit from the parent, but can be changed differently. So for example, you could set a different fire rate for different weapons. So in this example, in the one that I've made, once the parent had began shooting, it would call the function fire bullet, and in here the fire bullet function would cast to the top down player. It would get their location, and it would get the location of the barrels that I had placed on the player, so the barrels of the gun. After setting that, the location of that and the rotation of the player, it would then spawn the blueprint bullet and of course play a laser sound at the location. The way that I set up the bullet was that upon being created, after a delay of 4 seconds it would destroy itself. This was to prevent problems such as a memory leak by having too many bullets within the world. Of course, when the bullet overlapped with an enemy, it then did a set amount of damage to the enemy. So when it when the enemy collision overlapped with bullet, it would get the health and set the health to minus 1 of that damage. It would then play a collision sound at that location before checking if the enemy health was less than or equal to 0. If not, it would just update the health to the new health. If it was true, however, it would set the enemy to dead and update the health accordingly. It would then cast to the top-down character and to the variable of kill count, which would increase in an increment of 1 each time an enemy died. It would then play a sound at the location of the enemy, and then it would spawn a robot gib or gib at the location. It would then play an emitter at the location of an explosion before destroying itself. This blueprint also make sure to check if the firing mechanic has been released, and of course it will stop shooting if it has done so. One issue that I came across when creating the shooting mechanic was that I wanted it to also work for the enemy, so that when the enemy was within range of the player character, it would begin to shoot. Unfortunately, I could not get it to work, and after a couple hours of faffing around trying to get it to work, I decided to change up the way that the enemy would attack, therefore saving myself a lot of time, so that I could focus on other things. The way that I changed this was that I set up the enemy to be melee attack, so when they came within range of the player, it would instead do a melee attack. And the way this worked is that when the collision was overlapped by the player, it would cast 2 the health, and it would decrease it by a set amount, and of course play a collision sound at the location. The next thing that I decided to create was health bars. This was done by creating a widget blueprint and using a progress bar, and then binding that to this here, which sets the health by percentage. And of course, when that is called, it will update the health accordingly. So over here, when the enemy takes damage from the player bullet, it will cast to the health bar widget, and it will update it accordingly. And the same goes for the player. When the player takes damage from the enemy, it will update their health accordingly to that as well. The next thing that I decided to create was the kill count, or the kill score. The way this worked was that a text box would be bound to a function, and it would be cast to the top-down player, and it would connect to their kill count variable and return that to the widget. Of course, every time an enemy died, the blueprint would cast to the top-down character, get the variable of kill count, and like I mentioned previously, increase that by an increment of 1 per character death, and of course play sound, etc. I then tied this into the blueprints for the lift, which would work as our progress. So the way that this worked was, upon play, it would cast to the kills required, and the kills required would be defined in the player blueprints and could be changed in the game. And what happens was, when the player overlaps with the collision box for the lift, it will first connect to the kill count of the player, the kill count variable, and it will check whether it is greater than or equal to the kill requirement. It will then, if true, begin to play the timeline for the animation for it to move up and move down. And this connected to the widget for the lift requirement. So the way that this worked was that it would get the kills required, cast it to the kill score of the player, and return that to the widget, and then it would say out of the kill requirement for the player. So the kill requirement also defined in the player, and that would then display above the lift. When the enemies died, they would spawn a basic giblet or robot trash, bit of scrap with some emitter sparks on it, and similar to the bullets, after a set delay that would be destroyed to prevent things, again, such as a memory leak. The next thing that I decided to work on was the pickup, and the way this worked was that every second that ticked by, it would set the relative rotation, and it would increase the rotation defined by this variable of rotation of pickup, which could also be edited in the game. When the pickup was overlapped by the player, it would then set the health of the player to the or it would take the health of the player and it would add the health bonus, which could also be edited in the game, and then it would play the sound pickup at the location before destroying the actor. Finally, I created the saw blade, which worked similar to the pickup blueprint. In each second that ticked by, it would rotate, and when it overlapped, or when the collision box overlapped with the player, it would look at the health and it would subtract a set amount of health from the player and play a collision cue sound at that location. The final thing that I decided to do was to duplicate the map that I had created, creating top-down level 2, and from there I added things, or I added two more. I added to it more by increasing the amount of barriers around the map, or the amount of cover, and by increasing the kill requirement by 10, which of course would mean that the kill requirement for the lift would increase as well. And then I duplicated that map to create map level 3, which did the same thing of adding more to it, such as saw blades, and increasing the kill requirement to 30, and the amount of enemies spawned as well, increasing by 10 per level, and decreasing their time until respawn. And as you can see, with each level, the amount of enemies increases and their respawn time decreases, as well as the kill requirement for the lift, which would take you to the next level. Finally, the last level that I have is a requirement of 50 with 50 spawned and a respawn of 2 seconds. When modelling this project, I decided to start off with 3ds Max. However, shortly into the modelling process, some issues with 3ds Max began occurring, so I decided to change to Blender. And I imported my robot model into Blender to carry on there. One problem that I came across when modelling in Blender was that when mirroring the object to create symmetry between it, the apply button was not appearing. I couldn't find the apply button. After doing some searching online, I finally discovered that the location of the apply button had been changed in different and older versions, changed from different versions of the software, so older versions were in a different place, and I had to find the new location of the apply button. I decided to use a placeholder texture when it came to UVing, rather than creating the texture straight away. This was just so that I could UV the models quicker and make sure that they were all UV'd properly before then applying the new texture to it. When it came to developing the stands on the left-hand side around the arena, I began by modelling one chair, and then instead of modelling multiple, I duplicated it before fitting it onto the stand. And I also decided to remove the backs and the undersides of the stands. Basically, the parts that the player wouldn't be able to see in game. This was to improve the poly count and to make it easier when it came to UVing. When modelling the health pickup, the design was simple. Much like other games, the icon would be similar to a medical kit with a big plus on it. Except this one would be in the shape of a cog to keep with the robot theme. One thing that I discovered is that the Red Cross does not like the usage of a Red Cross for health pickup items in games, due to it being a protected symbol by international treaties. First, the design of the pickup was changed in colour to respect that. Of course, it still had a plus, but I added the metallic colouring to it and the cog. Unlike some of the other models, I decided not to texture it and rather just to apply some of the default Unreal materials to it. This would save time when it came to texturing and implementing into the game. And so the same thing went for the robot scrap and the saw blades. I made most of the textures within Substance Painter. Textures for the floor and the ramp and the lift. And one other thing I decided to do with the game was to edit the lighting, so that rather than having the default light source that came with the top-down player, I decided to add spotlights around the map, just to give it the more aesthetic feel of being in an arena with floodlights lighting up the arena as if you're in some sort of pit battle. As I mentioned at the start of this video, I used FL Studio when it came to creating the sounds. I used some free sounds and effects downloaded on the internet just to create the sounds for lasers, for the robot deaths, for the collisions, and for the background music. And finally, I had the game, and it was all ready and ready to submit.